Welcome to Table for 92, element number 55, Caesium. It's number 55 because it has exactly 55 protons within its nucleus. For Caesium, we're cooking up some Spätzle, really popular food from the southern part of Germany. This is where Caesium was discovered by Robert Bunsen, yes, the dude from the Bunsen burner, and Gustav Kirchhoff, while working at the University of Heidelberg in the 1880s. Since Caesium isn't really found in foods and has no biological role in the human body, I'm going with Spätzle. It's so good. I've heard people call it German mac and cheese, but it's so much more than that. Caesium, though, incredibly important element, and like so many of the elements, we have found both wonderful and downright evil uses for Caesium. Caesium was discovered by Bunsen and Kirchhoff in 1860, but the only reason they discovered it was because they had invented the spectroscope and the Bunsen burner in the previous few years. The spectroscope, though, was a huge step forward in the search for discovering the universe's unknown elements. It allowed us to observe the spectral lines, like the light from the sun only produces a continuous spectrum of the colors of the rainbow. But by burning different substances, like the metal Caesium, and observing it through a prism, you produce lines of very unique color that help to identify previously unknown elements. Bunsen and Kirchhoff did this by processing 180 kilos of the mineral lepidolite into just a few grams of salt. And when burnt on the Bunsen burner and observed through the prism in a spectroscope, two beautiful bright blue lines appeared. This kind of spectral line had not been seen before, and Bunsen and Kirchhoff knew they had a new element. They named it Caesium after the Latin caesius, the word used to describe the blue color of the sky. So Caesium is absolutely terrible for you. If found in foods, it's because something terrible has happened. It's famous for being released by nuclear bombs or nuclear power plant meltdowns, but it's really specific isotopes of Caesium that are so dangerous. The only naturally occurring Caesium in nature is Caesium-133. It's a stable isotope, Caesium's only stable isotope. All the other prepared Caesium isotopes are unstable, meaning they're decaying, meaning they're radioactive and super dangerous. Pure Caesium, which is not found naturally on Earth, like many of the elements on the periodic table. Caesium by itself is a silvery metal, but yeah, you won't find that out on a hike or something. Like granite, the rock granite is fairly high in Caesium. It's got like 1 part per million. So yeah, it's not really a big deal. It's really when Caesium is tampered with by us humans that it becomes dangerous. Pure Caesium, like the other alkali metals on the periodic table, reacts super violently with water, which honestly would be a lot of fun to just like throw a hunk of pure Caesium in a pond and watch it like blow up and dance around, but I've been advised that would be a bad idea. Fine. The isotope Caesium-137, that's the stuff that gets released from nuclear fission. But again, if you come into contact with any of those unstable radioactive Caesium isotopes out there in the wild, it's because we as humans have done something terrible or have had some kind of terrible accident. Caesium-137 emits both beta and gamma radiation, which if you remember, it's gamma radiation that gave the Hulk his superpowers, but in real life there is no evidence to suggest being around gamma radiation emitted from Caesium-137 will lead to any kind of superpower, which is rather unfortunate because the Hulk would be a fun guy to have around. Caesium-137 is produced from nuclear fission, either from nuclear power plants or nuclear bombs. In fact, we are probably exposed to very small amounts of Caesium-137 every day in the air we breathe because, we humans, for some reason, thought it would be a good idea to test over 2,000 nuclear weapons on our precious Earth since 1945. And even though we've really cut down on the testing of nukes in the past few decades, all those bombs releasing Caesium-137, it's still floating around, Plus, a bunch of Caesium-137 was released in the nuclear power plant disasters in Chernobyl in 1986 and Fukushima in 2011. Chernobyl was much worse, though. Its estimated maximum calculated external dose of Caesium-137 was 10 times higher than Fukushima. Plus, on top of that, Chernobyl happened in the dying days of the Soviet Union when they were trying to pretend everything was going great in their society and didn't want to admit to the world they just experienced the worst nuclear accident in human history. So they didn't tell the rest of the world about all that nasty radiation spreading around until it was kind of too late, it was already all over Europe. Over time, though, the radiation dissipates, so it's really small amounts nowadays. Like, you're really only in danger of Caesium-137 poisoning if you're around really high concentrations of the stuff. Even though Caesium-137 is radioactive and bad for you, it is used in a lot of really important ways. In small amounts, Caesium-137 is used in Geiger counters to help calibrate the measuring of radiation. And in higher amounts, Caesium-137 is used in medical radiation therapy for treating cancer. But on a daily basis, probably the most common way we use cesium is in some of the world's most accurate clocks. So, you know, the idea of linear time, like 60 seconds in a minute, 60 minutes in an hour, and 24 hours in a day has been around for a long time, since the Babylonians. But in the 50s and 60s, scientists actually designed a new second, like seconds of a minute, based on the timing of Earth's orbit around the sun, which in turn is based on the ground state of Caesium-133. In 1967, this was formally adopted as the way we measure time. Officially, it goes like this. Quote, "The second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of the Caesium-133 atom." That's what a second is. So, cesium is harmless when found in nature in its stable form, but causes radiation poisoning and cancer in unstable forms, but also helps to treat cancer, while all the while has become the standard for how we measure time. Absolutely fascinating. Boy, is Spätzle delicious. Definitely try this at home, perhaps while pondering the exact nature of what a second of time truly is. Thank you. See you next time. So please like and subscribe. It's how I validate my existence, you know, getting more subscribers.